All right, here we go. Welcome, lesson 10.7, geometry notes, circles in the coordinate plane. Pretty straightforward, I think. Here we got one note. You can see it here. We'll talk about what is the standard equation of a circle, and it's basically a couple different applications of it. Graphing it, you can see that's the last thing we'll do is graph it given its equation. These other three examples all involve us writing the equation, given some information. So let's do it. Let's add this part to our notes. This is what we need right here. It's this crazy looking big old formula, quantity x minus h squared plus y minus k squared equals r squared. It's similar, actually. It has a distance formula feel to it. So yeah, make sure we get what all that stuff stands for. So in class, we took the note, heading was standard equation of a circle. We wrote the equation out, all these different variables, but then we basically cleaned it. I mean, the same stuff that's here. We said HK, the coordinates HK are the center of your circle. Okay, so you can see on the picture, obviously, we've got, whatever those coordinates are, right and up in this case. R is the length of the radius. So potentially there might be, I mentioned it a second ago, some distance formula stuff. How long is my radius? And then X and Y represent, and kind of put a pin in this, we'll come back to it, but they represent all other points that fall on your circle. So we said that just to make it official here. R was the radius length. And we also put that the x, y, which are just going to be a part of our equation, they're going to stay there. They represent, though, the reason they stay generic x, y is they represent all other points, or all points that fall in the circle. All points that, let's say, lie on the circle. All right. So, yeah, a lot of stuff going on. 5 different things, I guess, but I would argue one group, a second group, and then our radius. So let's take a look. How do we do this? So here's kind of one deal. I don't really there's no numbers on the page, obviously, other than, the coordinates here on our coordinate plane. So we're going to have to pull out, like I want to reverse out of this. Like, hey, I can look at this and see the center of my circle is right there. So my center is the point 0, 0. Okay, awesome. And radius wise, I can get that right off the picture as well. I'm going to count, in this case, up 2 tick marks and say my radius has a value of 2. That's all I need. I guess I'll put the formula up here so we can kind of get used to it. X minus h squared plus y minus k squared equals r squared. But basically at this point, it's a matter of just getting everything where it goes. For our center, we said that was point H. We're going to use that for H and K. We'll use this for R. Let's fill it in left to right. Just, parenthesis, X minus, all right, what's our H? 0. Quantity squared plus, I'm just kind of flying down the line here. Parenthesis Y minus, all right, our K value is 0. So 0 squared equals my radius squared. So that's just a step where I've kind of put everything where it goes. The only thing I'll ask you to do here is simplify kind of where possible. So this one, actually, all 3 stops have something that should be simplified. This is the one time. Anytime it's x minus 0 or y minus 0, we can actually do that, right? X minus 0 is just x, right? X take away nothing stays at x. So that part actually gets simplified to just, hey, x squared. For the exact same reason, y minus 0 is just y, so y squared. So both of those get simplified. And then our last part, hopefully, 2 squared, 2 times 2, 4. And that's how we leave it. There's our standard equation of a circle, x squared plus y squared equals 4 for this particular circle, with a radius of 2 and centered at the origin 0, 0. All right, cool, sweet. So far, so good. Example 2, keep her moving. Same direction, write the standard equation of a circle with center. Hey, look at that. I don't even have to pull it off a graph on this one. It's giving me the center, H and k, and wow, radius. So this one just straight up gives us all the information we need. I'm going to keep writing it until we kind of get the hang of it. X minus h squared plus y minus k squared equals r squared. There's our generic standard equation for a circle. I've got everything I need. We're just going to literally copy it down. X minus, let's see, we said h was 0 squared plus y minus, let's see, my k is negative 5 squared equals my radius. Not an awesome number as far as whole number, but we'll survive. All right, so I've just everything where they go. Just like the last one, it just works out this way. It doesn't always work this way, but I'd say there's all three stops need to get simplified. We saw this already. X minus 0 is x. For this part right here, this y minus negative 5, all I'd ask you to do there is just minus minus. We should just turn that into a big plus. Y plus 5 squared. And then I got to pick up my calculator because I don't want to try to do that one in my head. 3.7 squared, we're talking 13.69. And we leave, whoops, wrote it backwards, 9.6. A little inversion there. 13.69. There we go. So this part right here with this y plus 5 just gets left like that. We don't drop in the squared. That's not how that works anyways. You would never turn that into like y squared plus 25. That's not how that goes. Just leave it just like that. All right, so far so good. Third one, we're cruising. So I think as far as difficulty level, this is probably about as tough as we're going to see. So let's read through it. The point, negative 3, 4 is on my circle with center, negative 1, 2. Okay, so that's fine. Write the standard equation. So same direction 3 times in a row. Obviously the difference here is we don't know the radius, right? It gives us the center, which, okay, great. That's my h and k. I like that. We've done that now 3 times in a row. But yeah, obviously we said we changed kind of information on us a little bit. And it just says, hey, that point is on the circle. So what's the game plan? Let's start generic again. I'll write it for the third, maybe it's the third or fourth time. X minus h squared plus y minus k squared equals r squared. So I'm actually I'll show 2 methods here. The first method, well, whatever. Right? Well, I'll just show them to you. I'll give you some options as far as how you want to approach this one. Because I mean, I think at this point the whole left side I could get done, right? I could go x minus h, which is negative 1, plus y minus k, which is 2 squared. And we already acknowledged that, hey, r squared, yeah, we don't know it, but like for sure, that's pretty cool. X plus, other than just simplifying this part of it right here, x plus 1 squared plus y minus 2 squared equals r squared. So it feels like the left side of this equation, this can be my answer step, I guess. We'll leave it here like this. We'll come back to this. As soon as I figure out what the radius is and square it, we'll substitute it in right here and be done. I guess, how do we do that? So going back when I said put a pin in that x and y, what that represents, in this equation, in all equations, the x and y represent points on that graph. So this literally says the point negative 3, 4 is on our circle. That means that I could, and I think it's going to benefit us, if I plug in the x value and y value of a known point on the graph, if it helps us, which it will in this case, we can use that information to help us solve for r squared, or r. So that's kind of the first method here. Is you start generically with the equation of the circle, you get your center input there, and then basically come back to this point here, negative 3, 4, and just that's an x value, y value. Let's plug those in. So for x, I'm going to plug in a negative 3. I've already got my plus 1. That's part of my formula. Plus, let's see, my y value is 4 minus 2 squared equals r squared. And all of a sudden we go from something with 1, to 3 variables, unknowns, right, to now something with 1 unknown, and it's on one side of an equation. So I literally just have to crunch this left side of the equation. Let's do that. All right, so -3 plus 1 is -2. I'm going to have to square that. 4 minus 2 is 2, which we're also going to have to square, and that's going to be equal to r squared. So sweet, -2 times -2 is +4. 2 times 2 is 4. So when it's all said and done here, 4 plus 4, 8 is equal to r squared. Now, that was not my answer, but I mean, I think we're almost out of the woods here. The thing with this one, with the finish, sometimes people get confused. What was the hang up here, right? Going back to this step, we said, man, we're like almost done, other than the fact that we don't have r squared. So we technically don't even need to know what the radius is here. I could square root this. It's not going to be a nice number, right? A little less than 3, some continuous irrational number. But why don't I just say, hey, you know what? We were looking for r squared. I just figured out what r squared was. Just plug it in there. 8. Okay, so sometimes on the finish, people want to square root this number and do some weird stuff with it. Yeah, that is my r squared. Leave it there, plug it in, we're done. So in the end, that was my kind of answer step. X plus 1 squared. I did the simplify part of it. Y minus 2 squared equals 8. All right, so that's method 1. Uses our formula for circle. We plug in the x, y coordinate of a point we know on the circle, and we solve for r squared. I'm actually going to clear it. Well, I'll leave the formula part, the generic part here. But just to kind of give you a second option, sometimes people do well with that one, but sometimes not. So the other situation would be just to kind of look at what's going on here, right? We've got, and I'm not saying you have to make a picture, but even if I was just making kind of a generic deal here, the center of the circle is -1, 2, somewhere right here. And this point -3, 4 is on my circle. So I'm not saying this is exactly what the circle looks like. I don't know the radius, so I didn't know how big to make it, but I had this point -3, 4 out here. And then we had our center, which we said was the point -1, 2. And if I could just figure out what this distance was, this r, this radius, we'd say, hey, we're good to go. So this one actually involves the distance formula. It's good to refresh it, good to see it anyways. So I'll put it up here generically. It's a second formula. That's why sometimes people kind of shy away from this method. It's like, well, you're asking me to know the circle formula, Mr. Kroll. I also need to know the distance formula, although it's something that we've done quite a bit of this year, so I would hope it's something we could use. So there we go. There's your distance formula. We'll do it. Why not? Let's call this x1, y1, and then x2, y2. All right, and then it's a matter of just getting everything kind of plugged in where they go. So let's see, x2 minus x1 plus y2 minus y1. Simplify. Now you're going to see here, if you're following the last method, these numbers start to look kind of familiar. What's -1 plus 3? 2. We're going to square that. And then 2 minus 4 is -2 squared. Now I erased everything. I cleared it, so unfortunately they're not still there. But we just saw these numbers, 3 minutes ago? So 2 squared is 4. And -2 times -2 is another 4. So we end up with a radius, the actual distance between our center and the point that we knew of, the square root of 8. Now again, we just talked about, like, that's not a nice number. I don't even really want to see that as a decimal number. But we now have the radius, it's the square root of 8. We have the center. Can we squeeze? I'm not going to go back to the generic formula, but we can start to plug all that stuff in. I guess I might have to go back because I can't see it. Can I section this off here and do it here? X minus my -1, which was part of my center, my h, y, I don't remember, 2. What was the coordinates of my center? 2, y minus 2 squared equals my radius. But what do I have to do to that radius? I have to square it. Maybe you're seeing like, oh, okay, it's going to work out now. So the finish, here's my final, same as before. It's not different. It's just an alternate kind of way to get there. X minus -1, which is x plus 1 squared. Y minus 2 squared. And then the square of the square root of 8 is just going to cancel those out, and it's going to leave us with that 8 there. So that one we actually have to do, plug it back in and square it to get rid of that square root. So your call. I'm not going to mandate one way or another. Method 1, method 2, it's probably about the same amount of work. So it's not like one's a super short way to do anything. So, all right, that takes care of all the writing stuff. Writing equations, given a variety of information, given the radius and the center, pulling the radius and center off of a graph. Here, given a point in a center, kind of working back and figuring out what that radius is. The only other thing I would ask you to do is use the information, kind of sift through the information in the equation to help us maybe make the graph. Okay, and that starts with identifying those 2 key points there, that center, not even points, the center, which is a key point, but then the radius. So let's do it. What's the center here? What's the radius? So the most common mistake here is to look at this and say, oh, I know my h and my k. It's -2 and 3. But if we think back to all those 3 examples we've done so far, how does this formula work? It's x minus, whatever h is. It's y minus whatever k is, and it's equal to r squared. So the fact that it's set up as minus means this must have been, I guess, a -3 when I plugged in there, y minus -3, right? We've seen that a couple times already. Y minus -3 turns up looking positive. This must have been just 2 because then it showed up looking like x minus 2. So I guess long story short, however you need to think about it, it's going to be backwards than what it looks like. So the center of this particular circle that we're being asked to graph would be the point 2, -3. Right? So if that's how we're going to remember it, hey, it's backwards. Fine. It looks like -2. It looks like +3, but it's actually +2 and -3. That's fine, as long as we remember that. And then just don't mess this part up either with the radius. It's the radius squared. So I need the square root of this number, not 16, but the square root of 16, which is 4. All right, so if I can pull that out of the formula, that's all I really need to graph. We're not going to get super crazy detailed in making our graphs. What are we going to do? We're going to put the center on the graph. So the point 2, -3 would be right here. We don't have to label it because we've got it kind of labeled here. And then we're just going to use our radius to go north, 1, 2, 3, 4, south, 1, 2, 3, 4, east, 1, 2, 3, 4, and west, 1, 2, 3, 4. All right, these right here, these 0.1, 0.2, 0.3, 0.4, it's reserved for those 4 points that we just came up with. So there's no particular order. You don't have to label them in any particular order, but just tell me what those 4 points are. So like this one, for example, up here would be the 0.21. So somewhere on my point list, I should have the 0.21, whether it's the first point or the last point, I don't care. Let's see, this point over here would be -2, -3. So I'll put that on my points list. This point down here would be 2, -7, 2, -7. And then this one over here would be 6, -3. And you can definitely use that radius, right, and add and subtract to all your x and y coordinates, right? We added 4 to that y coordinate here, and that's where the 1 came from. I think it's just as easy to just count your tick marks like you did a long time ago when you learned how to graph points. So again, those can be in any order. The last thing we were being asked to graph a circle. I haven't graphed a circle yet. I've got some key points there. So just do the best you can. Connect those 4 points using a nice smooth curve circle. It's good enough for me right there. Okay, just no straight lines. And that's it. Okay, so that's kind of the second direction. You start with the formula, pull out some key points, or at least a key point and a key number as far as the radius. Use that to then get some points that we can help make our circle. So that's it. There's lesson 10.7. We graphed it, given the equation. We wrote a couple different ways of writing the equation, or at least we wrote it the same way, given a variety of information. We're done. Lesson 10.7 in the books. Let's call it there. I'll see you in future lessons.